In this video, we're going to be looking at factoring polynomial expressions by finding the greatest common factor. Factoring is basically the reverse process of the distributive property. So if you had something like this, 3x squared times 5x plus 1, and we multiplied it by doing the distributive property, we'd end up with something like 15x to the third plus 3x squared, right? And that's just using the distributive property. But what if we wanted to go from this to this? We wanted to go backwards. Well, we can do that, and it's through the process called factoring. So let's go ahead and take a look at how we would factor some polynomial expression by first looking at how to find the greatest common factor. So in this, we're asked to find the greatest common factor of the terms. So basically what that means, the greatest common factor, is essentially the biggest number and variable component, like all of the pieces, the biggest thing that can evenly divide into all of the terms, every single term. So when you're trying to find the greatest common factor, you can do it one of two ways. You can basically break down all of your numbers into their prime factorization and then just pick out the pieces that you find that they all have in common. Or you can just try and figure out kind of more intuitively, asking yourself what are factors of each of these that go into all of them. So I'll kind of show you both methods. So for the first one, let's take a look at the breaking it down completely. So I'm going to look at each term individually, and we're going to kind of ignore the signs for right now. We're just going to deal with them individually as the terms without their signs. So 4x cubed. So first, what is 4? 4 is just 2 times 2, and then x cubed is x times x times x. Right, so that would be its breakdown. 12 is 4 times 3, so it's 2 times 2 times 3, and then x squared is x times x. 8 is 2 times 2 times 2, it's 4 times 2. So 2 times 2 times 2 times x. So if we're trying to find the greatest common factor, we need to figure out what do all of these have in common. Well, all of them have at least 1 2, and actually all of them have at least 2 2's. This other one has an extra 2 and this one has an extra 3, so those are not something that they all have in common. So they all have at least 2 2's being multiplied together. They all have, this has 3x's, this has 2x's, this has 1, so they all have at least 1x. So your greatest common factor, sometimes it's called the GCF, is going to be the product of all of those factors. So 2 times 2 times x, which is going to be 4x. So the greatest common factor of this is 4x. So, and if you look at this, 4 is the biggest factor that goes into all of these evenly. The only factors of 4 are 1 and 4. And so 4 goes into this, and it also goes into all of those. And then all of them have at least x to the first power, and that's why we get 4x to the first. So let's take a look at trying doing this the other way without kind of breaking it down completely. So in looking at all of these have v to some power, and they all have at least v to the second. So this has a v to the second, this has a v to the third, and this has a v to the fifth. So they all have at least a component of v to the second. So that's our variable component of our greatest common factor. Now, are there any numbers that all of these are divisible by other than 1? Well, 5 is divisible by 1 and 5. 10 is divisible by 1, 2, 5, and 10. And 15 is divisible by 1, 3, 5, and 15. The one number that all of these have in common, other than 1, is 5. So 5 is the biggest integer that will go into all of those. So 5v squared is our greatest common factor. For this example, I want you to try and find the greatest common factor of these two terms. So go ahead and pause the video and see if you can figure out what the greatest common factor is for each of these two expressions. All right. So if you look at this, all of these are divisible by 4. 4 is the biggest possible common factor because it's the coefficient here. So all of them are divisible by 4, and all of them have at least b to the first, so 4b is going to be my common factor. Now this one was a little trickier because you probably, or maybe you were roped into the trap of all of them are being divisible by 12. 36 is divisible by 12. 24 is divisible by 12. 12 is divisible by 12. All of them except this one can be evenly divided by 12. So because this one can't be divided by 12, the 18, we cannot have 12 be our greatest common factor. So then what do all of those have in common? They're all divisible by 6. 6 is the biggest number that all of them are evenly divisible by. And then all of them have at least n to the first power, so that's why 6n is our greatest common factor. So how do we use the greatest common factor to help us actually do this process called factoring? So factoring essentially is undoing the distributive property. So the first thing that you always want to do anytime you're asked to factor is figure out what is the GCF. What is my greatest common factor? So in this situation, all of them have at least x to the first, and all three of these are divisible by 3. So if we're trying to undo the distributive property, essentially what we're asking ourselves is, if I were to multiply all of these, right, if I were to multiply something by my greatest common factor, I would get this. So we're trying to essentially multiply 3x into some thing to get 3x to the third. So you can ask yourself, what would I have to multiply 3x by to get 3x to the third? Well, 3 would have to multiply a 1 to give me a 3. And then I have x to the first here, and since I need an x to the third, I'm going to need to multiply by an x squared, because remember, you add the exponents. What do I need to multiply 3x by to get a negative 12? Well, 3 times a negative 4 would give me negative 12. And then x to the first, we'd have to multiply by another x to the first to give me x squared. What would I have to multiply 3 by to get 15? Well, I'd have to multiply by a 5. And then x to the first times what gives me x to the first? Well, I actually don't have to multiply by any other x's because we would have what we would need through this process. So factoring, the result of factoring this is going to end up being 3x times x squared minus 4x plus 5. Now, the nice thing about these is you can always check your answer by just doing the distributive property, and you should end up with what we started with. So go ahead and try factoring this one on your own. Remember, the first step is to find the greatest common factor, and then pull it out. Ask yourself, what would you have to multiply it by to get your result here? So go ahead and pause the video and try and work through this problem. All right, so in doing this problem, you probably found that the greatest common factor was 6m squared. All of these were divisible by 6, and the highest degree of m that we had in all of our terms was an m squared. So then we pull the 6m squared out and ask ourselves, what do I have to multiply this by to get this? So 6 times 1 is 6. M squared and m squared would give me m to the fourth, so it would just be an m squared. 6 times a negative 2 is negative 12. M squared, we need one more m to give us m to the third. And then 6 times negative 4 is negative 24. All of our m's are accounted for already, so we don't need to multiply by anything else. So this would be the factored form of this expression.